Students, I'll be talking about a very, very important thing. It probably may come in the exam that why halogens are ortho and para-directing groups. So before we discuss, first let me, give you a small idea. First thing is, in when halogens are attached to a benzene ring, we call them haloarenes. So I have taken example of chlorobenzene. You can see its first behavior. Since chlorine is a electron withdrawing group, that means it causes minus I. So it makes the ring electron deficient, okay? And due to this reason, it will show meta-directing behavior. Means when electrophilic substitution will happen, when electrophile will be attacked at the, halogenes, then the electrophile will go to meta-directing, meta position basically. It also shows another behavior because it has three lone pairs. So one of the lone pair will be in resonance. It's making a very nice conjugation over there, pi sigma lone pair. So as a result, lone pair will be directed towards the ring. And when the lone pair is directed towards the ring, the benzene ring will become electron rich. As a result, it will, redirect the incoming electrophile to ortho and para positions. It shows plus R effect. Now this plus R and minus I both are opposite effects. One says go to meta, one says go to ortho and para. So this is a contradictory, effects. So plus we have observed that normally plus R is more dominating effect than minus I. But only in case of haloarenes, minus I dominates plus R. So as a result, we assume the final you know, reaction will be based on meta direction, but that is not true. Despite the fact that minus I is dominating, halogenes still shows, ortho and para direction, but the question arises why. So, to explain this, I will explain it to you. First, what we will do, we'll draw the intermediate. First, we will, both the intermediates we will draw. First, we will assume that electrophile goes at ortho position and we'll draw the intermediate of that. Second, we'll assume electrophile goes to meta and we'll draw the intermediate of that because the answer is hidden there. So, in exam also, you will be explaining it like this by drawing the intermediates. So, first, you will draw this haloarene. Now, you will be drawing two intermediates. One, assuming that the electrophile is attacked at ortho position. Understand that whenever we do a comparison, we compare ortho para versus meta. So I'm assuming ortho with para also it will be the similar. So second, I will draw the electrophile is directed at meta. So let's draw both the intermediates. So understand when electrophile will attack here at ortho position, right? So this double bond will break. As a result, what will happen? The electrophile will attach here, but this carbon will come in loss. So plus charge will come here. So let's see this. So this is the expected intermediate. So these two bond will remain as it is. Chlorine is right here. Now electrophile is attached here, but this carbon is lost its one of the bond because of the breakage of this double bond. So plus charge came here. Now, if the attack happens at meta, then we will draw the another intermediate. So, in that case, the intermediate will be here. These two bond will remain as it is. Meta PU attached electrophile. This carbon came in loss because the double bond has broken. I hope that is clear. Now, if you see both the intermediates, the answer is hidden here. See, as you know, the chlorine is showing dual nature. It is showing its minus I also and plus R also. Now understand in this case, in case of ortho substitution, what is happening? See, when plus charge is there, it means you need to stabilize it. It means you need to compensate it. Plus means loss. But to make it worse, chlorine will show its minus I. It will pull the electron further. So minus I is going to create a huge damage at this plus carbon. But at the same time, what will happen? Some pulsar, because you know that halogens show pulsar effect also. So somehow this plus charge will be compensated at the same time by pulsar group, pulsar effect. That means loss is happening, but some gain is also happening, okay, because of plus R effect. Okay, so basically loss and gain somehow it gets compensated. Though we know that minus I is stronger than plus R, but still some gain is happening. Okay, at least something is there. But in case of meta substitution, what you will see that plus charge is now here, and if resonance will happen, right? So it will go here, it will go here, right? That means plus charge can form here, plus can form here. Plus will never ever come here. There will be no possibility of plus charge at this position. So minus I is still happening because chlorine is there, right? Minus I is there, but the benefit of plus R, which was happening in the above case, was because plus charge was there, right? So plus R was benefiting it. But since there is no plus charge here, right? So as a result, the benefit of plus R is gone. I mean, plus R is not possible. I mean, plus R will happen, but the problem is the plus charge goes here, here, and here. It's not here, right? Unlike the above case. So here only minus I is there. Plus R is not really making any, you know, benefit. Plus R benefit is gone, only minus I. So here only loss is happening, benefit is not there. Here loss is also there, benefit is also there. So I mean, you can understand because of this reason, there is no plus R benefit, right? As a result, what will happen? This will be more stable and this will be less stable. That is the reason, despite the fact that minus I is a stronger effect in halogenes, it is still ortho and para directing. Ortho and para directing groups. I hope that is clear and all the best for tomorrow's exam.